Okay, so here's our project. We have recorded it as a group, but I found out after I watched it that my voice didn't record great. And instead of me doing it, I just decided I told them that I would voice over. So here we go. This is group presentation. This is our group presentation. I'm Emilio, and I'm gonna start the video, and they should introduce themselves.
I'm Jason.
I'm Shalindra.
I'm Devin.
So we're gonna be doing the location 1, 4, and 7, and here's Shah.
Alright, so for our project, as he said, we're comparing the three locations, and as you can see from our first location here, location we have the original data compared to the curve fit line, which is the red dotted line there, or red dashed line there. The blue line is the original data minus the mean, and looking at it, we can see that the pressure, the highest peak is around 3, while the lowest goes to about -2 on average, but it's centered around 0. But it starts off very low at -5. But looking at it, we can see how the curve fit model kind of estimates the data pretty good right there, and that's for location 1.
Alright, so here's location 4, and as you can see, it goes from about -5 to 5, and we kind of labeled it as center because we would expect the ball to have, or the center of the ball to experience the most, I guess, pressure from the electromagnetic waves. And as you can see, it kind of dies down, and compared to location 1, it's just more, it's definitely has a higher rate of like pressure over time, and they're both similar shape, but yeah. Here's
Alright, so this is location 7,
Jason.
pressure versus time. Now this is out of one of the other ends, and as you can see, it doesn't nearly hit 5, -5 to 5, it's more about -5 to 4-ish. You can see it's a little more spread out than location 4 and 1, with the curve fit not being as straight, and varying a little bit in the middle.
So this is a comparison of it. As you can see, the blue wave is our original, and the green and the purple is location 1 or location 7, I believe. When looking at this, it shows the little red circles are the max points of each certain line. Depicting with this, we have the max points, and then max points versus time, and this is Fourier transform or an exponential decay, and as you can see, it shows like the type of envelope as what we're kind of looking for.
And then we're gonna look at the code. So as you can see, we kind of just loaded the data from the file. We looked at the pressures, loaded them in. You can see we have the center as location 4, as that is our guess. The ends are going to be the weaker ones, or the less frequency ones. We remove the DC component right there. We do the FFTs and the curve fit with an 8th order polynomial. We do the sample rate, and then we start plotting them. As you can see right here, we have the frequencies at the center, which is at 34 kilohertz. That's then at 2 ends we have 17 kilohertz. And here's Shai to explain some more in that comparison.
So just looking at the 3 different locations, as you can see, the ends of the location N1, which is location number 7, the pressures don't change as rapidly or as drastic time as in the center or location 4, and also the peaks and the lows of those 2 locations aren't as drastic as the middle location from our observation. That's our presentation.
That's our
You look nice today as well.